Welcome to Benchmarking Apache Druid Part 2, Under the Hood. And there's the purpose of today, before I start, is really to look at the work that, well, basically I benchmarked Druid using data warehouse workload, and essentially that gave me a lot of information about how making changes to my Druid architecture and to the hardware that Druid was running on, and how optimizing my queries and optimizing my ingestion spec actually could improve results. And the key to it all is really just simply understanding how Druid really works, because then optimizing it starts to make sense. Before that, it's like, well, I guess I could optimize this because Gian said it, which is usually a good thing to follow. But now really truly understanding how it works, I think would be helpful to everyone, or I hope would be helpful to everyone. I guess one thing, right, I have a picture here of a Honda, of an Acura Integra engine, because I have to tell a story. No discussion involving the term under the hood would be good without this story. So when I was like 23, I think, I went out and I saved up and I bought my first car, and it was this Acura Integra. And I didn't know whether I should get I'm really not a car guy. I didn't know whether I should get the GSR, which had a bigger engine and a better suspension, or if I should just get the regular L model. And the thing is that, like, when you stand outside and you look at it, what you see is two cars that look basically the same. I mean, one has a spoiler and a pinstripe. But really, the differences were under the hood. And where this becomes a funny story is that the first day I drove the car to work, someone pulled up next to me at a traffic light and did the whole, like, pointing at me, pointing at the light. And I got all excited, and it was the first drag race ever in my life. And the light turned green and I stalled. And so there you go. How you use what's under the hood is very important as well. Okay, so starting the talk. That was a little chit chat as people filtered in. All right, so I'll tell you about me. There's my beard. It's not my only qualification to be a Druid evangelist. I am also pretty experienced in enterprise architecture. I've been doing information and network security for many, many years. I've worked at many startups. I've helped many startups in what I call a technical marketing role, sort of a kicking the tires role, getting ready to go to market, stuff like that. Because of my background in epidemiology, as well as my background at PC Mag, I can basically test anything and do it in a rigorous and valid manner. I mean, we tested anything you could imagine, from like lines of code to hardware, which in some ways is lines of code, but anyway. And that's why, the feeling was that I was the right person to come in and run these benchmarks. And let's see, I also have a certification, a CISP certification, which is in security. And at the same time, I like to throw in a little tidbit about me personally, and that's that I like to cook competitive barbecue, which I'm not sure I even eat anymore. But it's always fun. I bet you didn't know there was competitive barbecue. And maybe someday we can all get together after this is over at some Imply event, and we can all enjoy some ribs or some brisket and tell some nice stories about how we're using Druid. Okay, so what I want to cover today is pretty straightforward. Just what is Druid and why is it so fast? I kind of wanted to shove an expletive in there, but I decided against it. Okay, so straightforward. Druid's a high-performance, real-time analytics database. And what does that mean? Well, let's go back to where Druid comes from. So Druid was created by MetaMarkets. It was written by the guys who are now running Imply and a couple other people. It was basically created to power an interactive app for digital advertisers, and that would be discussing data or showing reports and data on advertising usage and click-throughs, as well as cost, and reports on optimizing the ad or user engagement. And basically what happened was, as MetaMarkets was building this system, as MetaMarkets was building themselves, they tried other software and nothing could do what they needed it to do. So then they went and they wrote Druid themselves. And I'll tell you what Druid gives you that other things don't give you is real-time online, real-time analytics on streaming and historical data. These are a bunch of demos that are built using Imply Pivot, which runs on top of Druid. And this just shows how easy and how fast. Actually, let's leave easy out of this because Pivot's what would be easy. It's the fast part. I think any of you who have used Tableau or Looker or Superset know that if you're pointed at something slow, you might not have a very good experience. And one of the things that Druid does is it provides these super snappy experiences for people who are doing exploration and who are drilling down. I personally have spent an awful lot of time looking at Tableau, redrawing the screen, and I would like to say those days are over. But it's not so easy to do that. You face challenges in terms of scale and complexity, and in terms of the app you're trying to build. This was specifically about what MetaMarkets was facing. And what they did was they looked at a bunch of different solutions. Did they want to go the route of a search platform or a time series DB or your standard sort of pre-built OLAP cube? But none of those were really going to cut it. And in a way, they pulled parts from each of these to build what's called Druid now. Real-time ingestion, a flexible schema, optimizing storage, being time-based, batching ingestion, and running. So Druid, it's kind of hard to describe, which is interesting because in some ways the name Druid, originating from the Druid class as a character that's able to change his or her strengths and characteristics. It's kind of what Druid the system actually does. Okay. Now, trust me, bear with me for a couple more slides. I'm building the story up. We'll get to the point soon. So then Imply, so the founders of, the guys who wrote Druid started Imply, and Imply is built on top of Druid and also adds monitoring and some nice management tools and security and Pivot, which is the UI. But basically the core of it is Druid. And basically what we're talking about is sub-second query response. And to me, like, so one of the reasons I joined Imply was because I read the original Druid paper, which actually I have right here. I sleep with it. I'm kidding. I don't really sleep with it. It's just here to give me a feeling of security while I'm talking to you. When I read this paper, it just blew me away that there was, I had never encountered anything else that could actually change the way that I worked, or that other people worked, or anyone who works with data works, because it's just so fast. It's like unbelievable to me. The volume of data that can be queried so quickly. And now okay, here's the list of all the people who are running Druid in production. Actually, it's probably not all the people, because it changes every day as more people run Druid, which is great. But this is just a proof point. Okay. So when we talk about Druid and we talk about it being highly concurrent, we really mean it. There are people out there running massive clusters and entertaining entertaining sort of slice and dice and other reporting and dashboarding from hundreds of people concurrently, or systems concurrently. Druid does a continuous real-time ingestion, which is actually very, very cool. Like, you can have Kafka or something else stream into Druid, and it will ingest it. I'll go into detail about this later. And you can actually you can query streams very quickly while they're sort of in the process of being ingested into the system. You can query Druid using SQL. You used to have to use the native Druid, but now we are pretty close to fully SQL compliant, which worked out really good, because when I ran all the SSB stuff, that was all in SQL. And really, the goal of Druid is that everyone who's running Druid anywhere gets query latency that is sub-second to at most a few seconds. When we talk to people and they're experiencing like a 10-second response time, there's something wrong. So let's see. Then there are a lot of questions. When should people use Druid? Oops, I thought I was building the slide. Okay, so like we talked about, you have a large data set, right? Because actually speed isn't terribly important when you have a small data set. So you have a large data set and you need speed and scale. You need low latency ingestion from a stream that can be quickly queried, like for a monitoring use case. And also the speed to support interactive ad hoc queries, which is that sort of arbitrary slice and dice. Like, show me, oh wait, what's the example we always use is this, show me concert tickets in this city. Okay, now I have that. Now show me the concert tickets in that city by artist. Okay, now drill into Justin Bieber, right? So that's the, that sort of slice and dice. And when that's really slow, it's unpleasant. Druid also gives you the capacity to query both real-time streaming data and historic data with a single query. And well, the infrequent data updates, Druid, the thing Druid's doesn't actually do is change data. So once the data is in Druid, it's immutable. You can add to it, but you're not, well, you can actually kind of work around this using SQL, but since I'm talking about speed, I'm going to talk about Druid segments being immutable. In order to, you want to use the right data. If you bring the wrong data into Druid, it's funny. I always feel like that. There's this South Park episode where they go skiing, and the instructor always says things like, "And if you don't do that, you're going to have a bad time." So if you try to use Druid and you're not using data that's ordered by time, you're going to have a bad time. Druid's built to use data that is ordered around time. Now, you can. I mean, Druid will add sort of this arbitrary timestamp, so you can work with data that doesn't have a timestamp, but really, I think what we're looking for here are events and things that go in order of time, because basically that's how Druid ingests and how Druid queries. You want to work with streaming data. Now, I'm saying denormalized because this is the Druid, the open source Druid discussion. The Imply Druid version, you could go ahead and use straight on Star Schema data because there's support for wide joins. And then again, you want to look at data that has the dimensions in it that you want to filter and sort on. And that way, okay. So I had a slide, but I guess I dropped it. And people typically, given these characteristics, people typically use Druid for things like clickstream analysis, network telemetry and monitoring, ad tech, fintech, for fraud analysis, and for other methods of analysis that have to take place very quickly and are time based. Basically, anything where you've got a series of events and things that are time stamped, that's where Druid's going to excel. Okay, so if you go back to the original page, now we're going to start talking about how Druid works and how that plays into performance. If you go back to the original Druid paper, I mean, like, actually, I don't have to read my slides to you. You can see Druid, that's high performance. Like, looking at dealing with 100 billion plus rows a day, and sub-second to a few second query response time, like out of Netflix. By the way, I got this from the Netflix blog post. Like, this is not casual stuff. This isn't stuff that someone can put together and just wing it, like, without Druid. With Druid, you can. Well, you can't really wing Druid either. You have to plan Druid. So, looking at how you plan Druid, we have a whole explanation of what was going on before that wasn't good enough. And essentially, if you look at the way that we used to do things, I don't know, what is this, 20-ish years ago, basically, I used to do stuff like this. You have all your different data sources. You sort of ETL them in some way to get them into a common format, and then you dump them in a data warehouse, and you then have your different systems, analytics, or your BI tools or whatever connect to the data warehouse. And the problem with this is that, well, first of all, it's very time consuming. It's complicated, and it's not scalable. You have a lot of different processes going on that have to be coordinated. Actually, ultimately, the problem that I feel really started to happen was that this section here, that's the gathering the data and ETLing it into the data warehouse, just started to take so long that companies couldn't do it anymore when they had to deal with larger volumes of data. Okay, so then what did we do? We moved forward a bit to where we took all the data and we just kind of threw it all in one place, and we called that a data lake. And then we would process that before putting it into the data warehouse to make it available to the applications. Okay, so that sort of removes some of the time constraints that were put on the whole process by ETL. Okay, but the thing is that this warehouse, this was sort of what, I guess there are a lot of people still doing this, but I feel like this architecture like that first architecture sort of carried us through about 40 years of computing. This architect, well, also things are moving much faster now, but this architecture seems to have been outgrown much faster. And I guess what we're looking at now is something where you have where I shouldn't have replaced the data warehouse with Druid, right? This is what you would think you would do, but that's not actually what we would recommend. But basically, wait, let me go here. Essentially, the way we look at it now is that you have your raw data, and you would sort of massage that however you had to, bring it all together, have it in one spot. That would be the data lake. Then you can pull from it when you do all your analyses, or throw it up into a message bus, like Kafka, or even just have it streaming in through Kafka, and bring that then into an analytics database, and then build your end user applications on top of it. I guess what I left out of this drawing is the distinction, right? That I don't want you to think of Druid as a data warehouse. It's not. It's actually not a very good data warehouse because it's not a warehouse. It's a super fast query engine. So again, Druid's not a data warehouse. What I think we should do, or what really everyone that we work with thinks we should do, is use Druid to augment the data warehouse. Now, this is I'm talking about data warehouses specifically because I went the route of testing using the SSB, or the Star Schema Benchmark, and we did that intentionally. There's been a lot written about Druid as a streaming analysis database. What we wanted to do was establish Druid as an analytic tool that doesn't replace your data warehouse, but can be used. It's an adjunct to your data warehouse when you require kind of the ultimate in performance. So one way to think about that is this idea of hot versus cold. And Druid is for this hot stuff. Druid's hot stuff. And you could quote me on that. So Druid, it's like when you want to run super fast queries on fresh data. And that can be either for slice and dice, that would be like an analysis use case, or a dashboard that's used for monitoring something. These are timely decisions that need to be made, versus the data warehouse is sort of like something you throw data in and let it sit there, and maybe run a report every once in a while. And that's used more for planning. Now, my feeling here is that Druid and the hardware that Druid gets thrown on need to be optimized for speed and scale, whereas the data warehouse, because it's basically a big repository, gets optimized for cost and scale. All right, so now we're drilling into Druid more. these are some data structure reasons why Druid is fast. First of all, if you don't have to worry very much about writing, then you can read really quickly. So the first thing Druid does is work with immutable segments. Now, I guess actually I should say at this point that I'm going to kind of avoid the discussion of what's in a segment because I feel like that's what most people talk about, is how Druid ingests and puts things in segments and how those segments get written and how you can query them. I feel like that gets talked about enough. I want to talk a little lower level, or not storage level, but more of like how the system itself works. Okay, so another thing that's really important is that Druid uses compression. Druid is column oriented, and it uses compression, which makes it more efficient in terms of, well, definitely more efficient in terms of storage. The other thing is that compression is a CPU task, and we have a lot of CPU now. That happens to be the way computing has moved. Let's see, what else? We do dictionary encoding at a column level. So this is actually, you know what, I will get to this. But what's interesting about Druid is that things get read in, stuff gets read in, it gets held in memory, and it sort of gets processed. And then it gets written into these segments. And when it's written into the segments, it's encoded with a dictionary. And what actually becomes super important is understanding where the dictionary, what's in the dictionary. And if you can write your queries so that you're hitting the dictionary or the cache of the dictionary rather than reading the data off disk, then you'll have a better time. And then Druid also offers roll-ups for aggregation as well. There are, okay, I'm going to keep going. It's so hard. I have to tell you guys, I've reached this interesting point in my Druid journey where I feel like in January, I didn't know anything. And then I learned an awful lot. And now I know like enough that I think I've gone beyond knowing enough to be dangerous. And I've now gone into like knowing enough that it's like too much. And I have to like, it would be better if I knew less, because then I could explain it better. Okay, so something to understand about Druid is that it's got essentially two systems inside of it. This is how I think of it. There's this system that deals with ingestion, which is getting data into Druid. And then there's a system that deals with querying. And this is actually super important. And then on top of it, so it's like two separate pathways. So at the same time that Druid can be ingesting as fast as it can also be responding to queries as fast as it can. The whole thing kind of gets tied together with Zookeeper. Everything runs as a process, which is actually pretty awesome in terms of scalability and performance. Each sort of little box that you see runs as its own process, so it can be restarted or scaled independently. I think somewhere in this somewhere in the original MetaMarkets paper, FJ talked about something like no downtime for 3 years, despite upgrades and crash nodes, and because everything is its own process and things can be recovered. There's an external dependency on Zookeeper, which is sort of where everything advertises where it is and what it's about to, or where it is and what it's doing. For those of you who, like me, worry about external dependencies, Zookeeper, actually, if Zookeeper fails, the cluster can I guess, revert to a state where it's only using HTTP to try to track itself. Although the first thing it does is it goes back to its last known state, and then it will run from there. There's the metadata that gets saved about the cluster itself, the cluster's rules, and the data that's getting stored. That's typically an external MySQL or Postgres database. And then there's deep storage, which is usually S3. Let's see. So I guess the point I'm trying to make here is that there are two separate systems. There's one for ingestion, and then we'll get to the one for querying later. And I'm going to repeat it again, I'm sorry. It's important to understand that when you have this system, they're two separate systems, but they do work together, and it's important to understand how the behavior, it's not the behavior of the system, it's what the system does with the data. So how data is ingested will directly affect how your queries run. Actually, I'm just doing a time check. You know what, guys, I'm gonna skip how Druid processes stuff because I think we're gonna run out of time. But what's important is this idea that there are two different systems. Okay, so what we did earlier, I was saying it wasn't just it was like half of Imply at least helped me at some point. Run the Star Schema Benchmark. Now I have a link here to the Star Schema Benchmark if you'd like to download it yourself. I gave a talk earlier, maybe in June or July, where I actually laid out every step of testing using the Star Schema Benchmark and JMeter. And also there's I have a GitHub repository where I have detailed specs, detailed steps, as well as all the JMeter scripts. That's on it's under Imply data on GitHub. So I won't go into Star Schema Benchmark terribly. It's based on TPCH. Essentially what you have is a bunch of fake e-commerce data, and then some queries that some of them are very simple, and some of them are sort of multi-phase to emulate this OLAP slice and dice. And this, so part of where the idea came to do this was that these guys at the University of Minho in Portugal, and I'm sorry if I pronounced that incorrectly, wrote a paper where they looked at Druid versus Presto and Hive. And they basically concluded that Druid was really fast compared to Presto and Hive. And so what I did was I ran, see these are like on the overall data set. I ran the Star Schema Benchmark. Now, okay, this is kind of interesting how this talk is happening at this time, because we're about to release Druid 0.20. These tests were run on 0.19. And let's see, this query 1.1 and query 4.1, I can tell you right now, the performance was poor in Druid because those queries failed to vectorize. And a lot of work has gone into updating the query engine, and those queries vectorize now, and they're running I mean, they are literally running in under half a second. So, but don't tell anyone that. I am not publishing my final results yet. And yeah, I mean, there's an SSB. I'm not going to go through each query. Okay. So another thing that we then did was we compared the performance based on, or it's price performance. So it's a combination of performance and price for Druid versus several other cloud-based data warehouses, which basically Druid out. Look, the story is Druid's cheaper and faster. Okay, so that's what sort of were the outcomes of the testing, but in terms of performance. But there were also a lot of lessons that I learned from doing the benchmarking. And essentially, a lot of those lessons came from, okay, well, Matt did his best as someone who never touched Druid to just pull that data in and query it. Now let's try to make it faster. And learning how to how to run the queries faster and how to run the ingestion, not just to run the ingestion faster, but also to run ingestion in such a way, or organize the data and run ingestion in such a way that the queries would later run faster. Okay. The first thing that I learned was that what really affected performance was the size of the data node. The size of the query node kind of affected performance, but really it was the data node. When you're deploying and configuring, I'm going to tell you where you want to spend your money is in the data node, and you're going to want to use NVMe disk, not sort of standard disk. And that's the data node, not deep storage. That was the first thing. So I could scale each one of these components up or down, and I could see what the effect was under load, which was actually very cool. The master node, it's funny, you would think with a name like master, its performance would be more important, but it's actually felt like the least performance sensitive thing. This was how I tested in the end. I really like these i3 2XLs. Okay, so this is what I've been trying to sort of hint at the whole time, and I have to give a little hat tip here to Gian, who told me to go ahead and use his slides because he explained this so well. It's super important to understand with Druid that your ingestion and your query engine and your data format are all tightly integrated. None of them live alone. How the data is taken off disk and put and ingested into the system, and how each dimension is classified within the schema and managed, how the indexes are built and how the dictionary is built is super critical for your queries. Now, Druid always partitions by time. One thing I discovered was that by adding a secondary index, on a dimension that you commonly use to filter, you can make a huge difference in performance. For example, if I wanted to read in a whole year of data and then query for a particular day, it would be important to build a secondary index on day. And I mean, the difference is just so dramatic. You would notice it immediately in terms of performance. And I mean, basically, these are all the things that we accomplish by doing that. You know, it's also one thing that I noticed too is that it's important how you read in your data and where it comes from. You can't just sort of point Druid at something and read data in and expect it to ingest it optimally. You can point Druid at something and ask it to ingest, but maybe not count on it being optimal. And I'll explain why, right? So Druid builds these dictionaries and it runs its compression and it turns things into columns and it sorts them and it does all this stuff. But that's sort of all, if it's not done in the right order, you can either pay the price for doing all that stuff up front or pay the price for doing all that stuff later when you're running your individual queries. And I suggest that you pay the price for that up front by designing and by ingesting, knowing. So it's hard, right? How do you solve a problem when you're here? But like, you need to know how you're going to query Druid before you can bring the data into it, because otherwise you're not bringing it in a way that makes any sense, right? So now, in general, I think for performance, right, I mentioned focusing on the data servers. I'm going to offer a further proof point, which is that the vast majority of your data will live on your data servers. Well, and actually, if you did batch ingest and your data is not changing, it will all live on your data servers. So really, again, I'm going to come back to this, that you should invest in your data servers. So when Druid partitions by time, and then we build secondary indexes, and if we can sort in advance. So sorting in advance made a huge difference. I feel like if you, wait, I'm showing you here. Okay, this is what we kind of end up with. Now, all right, I'm going to explain why. And it's funny because I had made slides, but I thought Gion's slides explained it much better. Okay, so if you're going to read all this data in, we read in, what Druid does is it reads data in, it's building the dictionary, and it's managing the data that it has read in memory. When you know, it kind of builds these things. We are calling them chunks. They're not exactly, you know, they vary. So it reads stuff in, it reads into these chunks, and then it's going to write the chunks into the segment. But when it reads, it's going to read the chunks too. So if you imagine that as things get pushed into the chunks, if they get pushed in out of order, now it needs to read up and down in the chunk instead of just reading in order. And that's slower. Now imagine if it then has to read up and down in one chunk, in the next chunk, go back to the first chunk, aggregate, go back to the third chunk. That's a mess. That's going to take much longer. If we were able to sort it in advance and build an index on the field we were going to filter on, imagine how much faster that would take place. This just sort of explains what I just said, right? I mean, even if your eye scans this middle row, it's going to take longer than your eye scanning the right row, and a computer's faster. Okay. Now, how do you do this? Oh, another thing that matters, actually, believe it or not, it matters the order your columns are in. So rows are first sorted by time and then by dimensions in the order that they're put in. So, this is all sort of leading up to a lot of data. If you massage your data before bringing it into Druid, you're going to have a better time. Put it in order, sort it in order, sort your columns in order, and then sort your rows in order, and then import into Druid. And this is sort of explaining how all of this goes when you're writing your ingestion spec. And then, there's also this align your query granularity with your ingestion granularity. There's less math that Druid has to do while it's running a query. That's another thing that's a little tip. And then John made these. Here's an example of what it actually looks like. So if you look on the left here, this big part, going out and finding the data within those chunks that I described, and then bringing it back and decompressing it, and then querying it, looks like that. Being smarter about how the data was read in so that it's basically sorted in order and we don't have to flip back and forth between a million chunks in the segment, results in more efficient CPU utilization, and also just more efficient disk utilization, not disk utilization, but disk I/O, and faster query performance. Okay, so, it's a good thing I skipped those two slides. All right, I'm reaching the end here because I do want to leave some time for questions. I realize I've said an awful lot. The first thing that I want to do is I want to tell everyone that we want you to be active in the Druid community. It all sort of runs off of the Druid website, which is on druid.apache.org. All the different ways you can interact with us are listed on this /community page. Actually, Yelena, you describe this stuff way better than I do.
Doing a great job, Matt.
Okay.
I'd also like to comment about massaging the data. That's very Bay Area. Makes me think about massaging the kale first.
Oh, yes.
But yeah, Matt's doing an awesome job here. Community resources, but if you want me to take this slide, that's fine.
I'll keep going.
Okay,
I just thought you had unmuted yourself, so I thought maybe you were getting ready to jump in. All right. We have a lot of meetup groups, which I guess you have found at least one of them because you're here today, under Apache Druid. And there's the ASF Slack channel, #Druid, where I spend, I don't know, 8 to 12 hours a day, maybe, trying to help people out and answer questions. There's Google user groups as well. I'm going to plant the seed for a tease that there's something better coming. And you're going to have to stay active in the Druid community in order to learn what that something better is and benefit from it along with us. There's the @DruidIO on Twitter. If you want to get started with Druid, you can download the Apache distribution or the Imply distribution, which adds pivot. And then this repository of Druid benchmarking tools and scripts and stuff that I mentioned is there too. And that wraps it